Welcome. My name is Christopher Skack, and today we're going to talk about our RF waveform generation tool. This is our generic waveform tool for RF applications. As you may have seen before, we have introduced several different plugins available for our AWG70,000 series products. Today we'll be talking mostly about our RF generic plugin. As you can see, we are focusing our AWG product on several key application areas. And you can see that RF generic is one of the key waveform tools that we use for these different applications. As you can see in this slide, the RF generic plugin is used for pretty much every application area that the AWG is very popular in. The new plugin architecture for our AWG series gives the capability of providing plugins directly into the user interface of the AWG or through a separate program called Source Express that runs on a PC. So you won't have to learn a whole new application if you're running on your PC or if you're running on your AWG. Basically they all look the same, and these plugins go right into the interface of the AWG software. So again, you don't have to learn something new. Very easy to pick up and use these different plugins, since they are very similar in the way they work, and also the way that they interface with the AWG itself. So as you can see here, we have several plugins that are available today, and we'll be introducing more plugins as we go along. And in the future we'll also be able to connect these plugins to other products and work with other products as part of the software architecture. So the RF generic plugin is basically a generic waveform generation tool. And this plugin gives you the capability of building very specific RF type modulation waveforms. The nice advantage of using an AWG for RF applications is that you can build waveforms that have all the anomalies, all the characteristics of a real world signal, so that you don't have to use multiple generators to create these signals. You can create several different multipath signals and other criteria that will affect basically how your receiver works, and you can do complete testing of your system using the AWG as a single tool to create these waveforms and run these waveforms, so that then you can test your system appropriately. So some of the key features that are available in the RF generic plugin, basically you can define many different types of waveforms using custom modulation, digital modulation, analog modulation, and noise signals. So you can also create multi-carrier. You can define RF or IQ type waveforms, and each carrier can be independently defined with its parameters. You can create baseband data generation, defined as an IQ based signal, and different modulation schemes. And you can see that we have a substantial array of different modulation schemes available in this plugin. So the IQ impairments give you the capability of creating specific impairments that you want to test your receiver with, to see that your receiver can handle certain anomalies, like I mentioned before, that are in the real world environments that we see today. So you can also include noise interference, so again, to be able to build real world situations. The applications or the plugins automatically take into consideration the wraparound effect of when you're repeating waveforms. So you don't have to worry about this, and that's the nice thing about using Tektronix software to build these waveforms, is that we take all the considerations of the AWG itself into the development of these waveforms, so that you don't have to worry about them when you build your waveforms. We also provide the capability of adding S parameter files to the actual signal being created. So this emulates certain components that could be in the system. but you don't necessarily have to have those components when you're testing your device. You can just use the S parameter to represent or replicate what that loss is in your system. And so we provide the capability of you being able to put in the S parameter for the component that you're using or the loss of the system that you're using. You can add impairments, total impairment capability of sinusoidal interference, frequency offset, nonlinear amplification distortion, and then you can define your hopping characteristics. So this application gives you a lot of flexible features that are used in the RF application area. Okay, let's get started with the demo. So what you're seeing here is our Source Express software that's running on a PC. And as I mentioned before, this looks exactly like the AWG does as far as its user interface goes. So you're not learning anything new. Everything that you learn in Source Express will also work actually on the AWG hardware itself. The only difference is the connections to the instruments. Here we have basically I've created two virtual instruments, one for a 2-channel box and one for a single channel box, so that you can represent the way the AWG configuration that you own rather than just using an arbitrary one. So you can specify what type of virtual instrument you want depending on your particular hardware that you have. So you can go in and select the options that you want, either a single channel or dual channel box, and this can be identical to the actual hardware that you have. So I won't create one since I've already got two here. So right now I think I'm going to go ahead and use the 2-channel box, so I'll select that. You also notice here that I have two IP addresses of instruments that I've got that I am connected to through the LAN interface. So these instruments I can actually send waveforms to through the Ethernet. This way it enables me to create all the waveforms on my PC and my workstation, and then just drag and drop the waveforms into the channels that are connected to that particular connection that I have. You can only talk to one of the instruments at a time, so you would go in and pick the instrument that you want to send waveforms to, and then just drag and drop that into the display, and that would send the waveforms to the actual AWG. When you're actually connected to an AWG, then all of your functions work similar to what you would do as the actual hardware of the instrument. So if I hit play here, the actual AWG hardware, if I was connected to this hardware, would actually start running that instrument remotely. So this gives you the capability of actually running the AWG from your workstation remotely, and you can change all your settings as if you were running the AWG right in using the user interface on the AWG itself. So we're talking in this particular video, I want to discuss mostly our plugins. We have several plugins available, and there will be more plugins coming as we develop them. Today we have 4 plugins available, and I will be talking mostly about the RF generic plugin today. So the RF generic plugin is somewhat of a replacement for our RF Express software. It's part of the RF Express software for the general RF applications. So this is specifically for general type RF waveform creation. It doesn't include the radar capability, and that will be a separate plugin in the future months. So as you can see here, you have the total graphical interface of the software itself. So if I take a tour around the interface here, as I mentioned, this is your AWG connections, and then you have your waveforms listed here. If you have sequences, you can go in and list your sequences also from this table. In the main display is going to be your interface that you set up your waveform or create your waveform characteristics. So here we're using the RF generic signal plugin. The other toolbars at the top of the screen are the same as, like I said, on the AWG itself. So home display would give you the display of the actual waveforms, the criteria. This is a 2-channel box, so you can see that I could actually drag the same waveform into both channels. And then if I wanted to play them, then I could just play them here. The next tab would be our setup tab, and this gives you the capability of setting up the vertical characteristics, the timing or the clock characteristics, and then also your trigger characteristics. So this is your major setup menu. And the waveform plugin is where I'm actually using to create my waveforms. Sequence editor, this allows you to go in and edit your sequence. If you want to create a sequence, you would just drag your waveform into the sequence tab that you want to create, and you can build up to 16,000 steps in the sequence. So this gives you a lot of flexibility if you are repeating waveforms, or if you want to build a very complex set of waveforms that are in a sequence. Capture and playback gives you the capability of up converting or down converting a signal. So if you have an IQ type signal, you can add an IQ type signal, or you can use a IQ file, TIQ file, or whatever IQ file you have. You can load that into the system, or you can use each individual. If you want to have separate files, you can have each individual waveforms. So in this case, if you're using a 2-channel box and you want to load 2 separate waveforms, you can do that. Then you basically specify the frequency that you want your carrier to run at. So this is our capture playback capability. So you can capture waveforms or capture signals from our real-time spectrum analyzer or from an oscilloscope and then play them back. Pre-compensation is our tool for enabling you to create waveforms, removing the loss of the sin x over x response of the AWG, and also it will go out and do a dynamic cal of your system so that it's a true complete feedback system, in the sense that we send a waveform out through your lossy cables, connectors, components, and then look at that on an oscilloscope, look at the losses, and then pre-compensate the waveform, creating a correction file that then you can use to correct for these losses in your waveform, thus enabling you to create a much cleaner signal, removing those losses. So this is very, very useful where you have many components and you need to have very open eyes for your communication type signals or low EVM signals. So again, we're going to go back to our waveform plugin here. As we look at the plugin here specifically, each plugin has its own user interface, so each plugin will be a little bit different. In the plugin itself, we have the compile menu and also the compile setting menu. So most of the compile setting menus are very similar. They may be a little bit different depending on the plugin, but this one in particular allows you to compile. You can compile only and load it into the waveform list, or you can compile it and assign it to a waveform. And then if you're connected to an instrument, you can automatically have it play once you've compiled a waveform. You can set the sample rate to auto-calculate the sample rate depending on your characteristics of the signal that you're creating, or you can manually go in and set the sample rate that you want. Or you can set it as an oversampling feature, such that if you want 6 times oversampling, then it will calculate what the sample rate should be. And it knows which instrument you're talking to, so it will know what the characteristics are for the AWG that you're using, so that you know that you can't go past a certain frequency. Since I'm using the 2-channel box, you can see it's maxed out at 25 gigasamples. For a single channel box, then it would be 50 gigasamples. You can have it auto-calculate the waveform length, and this is dependent again on the characteristics of your generation tool that you're using. In most cases, you want to leave this automatic. So if you're creating a PRBS type waveform, you know that it's going to calculate the length of the waveform to make sure that it fulfills that PRBS requirement that you've set. You can also set marker data such that when you create a waveform, it will allow you to have a marker that's at the symbol rate or for triggering or for other capabilities. So this gives you lots of flexibility on the markers. We automatically adjust for wraparound, and this is when you're repeating the waveforms, you want to make sure that each waveform is starting and stopping identically so that you don't have a spur at the beginning or end of the waveform. We do this automatically, and this is one of the nice features of having Tektronix do the software, is the sense that we know the hardware and we can calculate the wraparound correctly so that you don't have to worry about that. In MATLAB you would have to do this yourself. So this just takes that work out of having to develop software on your own that does this wraparound. We normally want to fit to the full dynamic range of the DAC, so most times you want to use the full DAC range. And so this will affect your amplitude settings depending on the actual AWG that you're using and what your dynamic range is. So you have to take that into consideration. We also have the capability of, when you compile a waveform, to use the correction file that you created using the pre-comp utility that I showed you earlier. So this gives you complete flexibility for using this correction file. So this is very useful. So that's a compile setup menu, so I'll go ahead and close that now. So in the actual RF generation tool, to start with, you would want to select your signal format, either an RF IF type signal, or you can set an IQ signal. So this gives you the parameters of the particular signal that you're creating. You can set your carrier characteristics, and this will be basically dependent on each carrier. You can specify different frequency components. So you can build quite a few carriers, I think up to 1024 carriers. So this is a nice thing about using an AWG for a signal generator for RF applications, is that you can have multiple carriers on one waveform rather than having multiple generators creating your single carriers. So this is a very useful tool, and this is why AWGs are so popular in the RF industry today, to be able to build these very complex waveforms. So each particular carrier, you can specify your actual setup. So in this particular case, depending on what type of modulation you want to use or your pattern. So right now you can also set your amplitude and phase in here. First, specify your pattern type. In most cases you would probably be using a PRBS pattern type, and we can go all the way up to PRBS 31, or you can create a user-defined PRBS, or you can use a pattern specific to your needs, or you can actually load a file with a specific pattern that you use. So this gives you all the flexibility on the pattern side. Now you can use different coding. In most cases you would, depending on your application, but you can use gray coding or differential. For modulation type, we give you quite a variety of modulation schemes to work from. So these would be digital modulation schemes. So for instance, for QAM, you can go all the way up to 1024 QAM, and you can see that when we build these waveforms, it will give you a simulation of what the actual characteristics of that signal are. So depending on what type of signal you're creating, it will give you a good representation of the actual type of modulation that you're using. So you can also pick, of course, your symbol rate, and this would be for each waveform that you've got selected. So right now I'm working on this particular waveform. If I change the frequency here, it would be shown highlighted up in the above in the actual index of waveforms. You can specify your filters. Again, you have quite a variety of filters that can be used for your modulation, and also your alpha values can be selected here. Again, you have a lot of filtering capabilities built into the system, so you have a lot of window characteristics that you can use depending on the type of modulation you're using. And then of course the convolution length. In most cases, you don't have to mess with that. You can use the default values. So that's the basic setup for your modulation and characteristics. You can then go in and have the capability of turning on hopping, such that you can hop between one frequency to another. So you can specify quite a few variables within this hopping characteristic. So you can symbol hop. You can specify your hop duration, your hops per second, basically all the characteristics that you need for your hopping, how many symbols per hop, and then you can use, if you have a particular custom pattern, or you can use a pseudo random list or a range of hopping frequencies that you want. So this gives you a lot of flexibility. As you can see, when I turned on this hopping feature, it gave me an indication that hopping is being used. So when you're in the setup, you know that you're using hopping here. Maybe you don't want to use hopping, but at least it gives you an indication that you have turned that on. So you can go in and turn it off, and you notice that indication goes away. So for any of these tabs, if you do decide to use any of these special features, then you will know that when you compile that you have those turned on, and then you can easily go in and turn them off if you don't want them. You can change your setup pretty easily. So we also give you the capability of turning on some IQ impairments, and this is very useful for receiver testing, such that you can build your waveform such that it will give you the worst case condition for your particular receiver requirements. And so you can swap the IQ, see if your receiver can handle swapped IQ patterns. You can turn on carrier linkage, so this gives you the flexibility of setting the criteria for that. You can turn on quadrature error, so you can change the phase relationship of your quadratures, your IQ outputs. Nonlinear distortion, IQ imbalance. So this gives you all of the flexibility for these IQ impairments that many customers are using to test their receivers. So under power ramp, we will also give you the complete flexibility here of building a power ramp. This is very useful in many RF applications. So you have the flexibility of setting the criteria for your particular ramp functions. You can either be in a cosine or linear ramp function. You specify the amplitude levels, initial level, and the ramp duration, and then how many symbols, or if you want to see it in symbols or time. So this is also a very useful tool in many applications. We can also do interference addition, so if you want to add noise or sinusoidal interference, you can do that with the tool. So this gives you all the flexibility again for creating those real world type waveforms. Distortion, another feature that many customers are using for their testing, is to be able to turn on a nonlinear distortion, soft limiting or hard limiting distortion, and you can specify the operating point at which you want this to be enabled. So again, this is a very useful feature for doing specific receiver testing. Multipath is also a very useful tool, so that you can tell that if your receiver is going to be able to handle many multipaths from reflections, and you can change the characteristics of the reflections that you're going to be using. So this gives you a lot of flexibility, and you can do it in seconds or time also. So that is basically the setup and characteristics that we have in the RF tool. So it's very simple to build your specific RF applications using this tool, very straightforward. The other thing you can do is add S parameters. If you have components in your system and you want to build a waveform that includes those components, you can include the S parameter of that particular component, either from a filter manufacturer or amplifier manufacturer, or you can get it using a network analyzer. So we support up to 12 ports of SP files. So this gives you the flexibility of taking those S parameter files from your components and then embedding them into your actual waveform, so that you don't have to have those components in the system when you're doing your testing. You can just send the waveform from the AWG but knowing that that component is basically built into the waveform. And this is another very useful tool for AWGs in the sense that you can build all of this characteristics right into the waveform, especially if with the capability of 10 bits of DAC resolution on our AWGs. It gives you lots of flexibility as far as what you can do with these particular added characteristics that you want to build into the waveform. Now we also have the ability to cascade S parameters, so that if you have more than one component, you can add all the components that you want to use. These S parameters have to be of the same port number, but you can add plenty of them to your system, so if you have several filters or several other components in your system, you can add them as a S parameter. And we also have the capability of de-embedding the S parameter, so that you could create a file that has the de-embedding of the signal, so then you could try to replicate that into your filter network or your equalization system that you create on the other end on your DUT side, so that you can open up the eye considering the losses of all these components that are being used. In a short, that's basically the characteristics of our RF generation tool. So it's fairly straightforward. Again, you can do RF or IQ type waveforms. You basically set up the characteristics of the waveform that you want to use, depending on how many carriers you want to create. You can then compile it and then just send that to the AWG, and you're off and running. So this again is a very, very useful tool, and I think that anybody doing any RF applications will find this tool very easy to use and very functional for a lot of their applications. Thus, it will improve your overall testing time. You don't have to worry about figuring out how to program all this. You can just use this software to do it, or this plugin. So hopefully you can download this. You can get a 30-day trial to use it, either using Source Express as I'm using here, which is also a free download from the web, or you can plug it into your AWG and run it from your AWG with a license for a 30-day trial, and then decide if you want to purchase it. We have several different licensing schemes available. So hopefully this gives you a good overview of our new RF generic tool. Download it, give it a try, and see if you like it. Thank you. Have a great day.